Good evening, everyone. I would like to talk about the project database systems, and I hope my sh screen is shared right now. And this is database system CSCI-526-01W, prepared by me, Bilal Mushtaq, CWID 503555932. The title of the project is E-commerce Retail Product Management System. First and foremost, I would like to talk about the system. It is designed for a jewelry e-commerce store. It's a prototype, it's a use case, and it is designed to manage and streamline operations for a jewelry and watch retail business that can include product listings, vendors, customer information, order processing, and analytics. We're going to talk about all of this more in detail. The business purpose for the application is to store and manage detailed product information, including pricing, stock, vendor, category, to track customer orders, order details, and automate total calculations, to allow customer segmentation based on region via zip code, to support business insights through reporting, for instance, most sold items, revenue per day, etc., to maintain supplier relationship by tracking vendor information for each product, to ensure accurate historical pricing per order without being affected by future product price changes. How this happens, I'll show you. So operational scenarios, we have multiple stakeholders. For instance, an admin. They can add, update, or delete products, vendors, customers, and categories. They can track and fulfill customer orders and monitor inventory levels. They can run reports like top selling products or revenue by customer. In this case, a customer conceptually, they can place an order that may include one or more products. Their address and zip code are tracked for regional analysis. As far as management is concerned, they can view analytics to make stock or marketing decisions. They can understand, what kind of products need to be stocked and which vendors are performing better than the rest, and the customer spending patterns as well. The technical constraints. The platform we're using is Microsoft Access. All the tables are normalized into the 3NF form to eliminate redundancy and maintain consistency. We are ensuring data integrity because we are using primary and foreign key constraints that are enforced between related tables. Referential integrity is going to ensure that only valid connected records exist, no orphan records in this case. And we're going to use more than 10 queries to, understand business information decisions, how they can be used to extract that vital information. And every single table is going to consist of 15 to 30 records. We're using foreign keys between them based on the following ER design that I'm going to show you in the next slide. The functional dependencies are as follows. The order ID is determined by the customer ID, order date, total amount. So this table contains all these fields. Order details, the functional dependencies are determined by order ID, product ID, quantity, price each. The product name, description, price, stock quantity, category ID, vendor ID are determined by the product ID. The customer ID determines first name, last name, email, phone address, zip code ID. Zip code ID because, we have created a separate zip code table because we didn't want any transitive dependency in the customer table because that violates 3NF rule. The zip code table contains the zip code, city, and state. The category table contains category name, description, and then the vendor table contains vendor ID, vendor name, email, phone, and country. We're going to talk about all of this more in detail. Let's have a look at the ERD. It showcases how referential integrity constraints are implemented. We have all these tables, the vendor table, the product table, the order details table, the category table, the orders table, the customer table, the zip code table. How these two tables are different is that any single customer, when they place an order at a single time, they can order more than one products. So their order ID is going to be one, like a single order ID, but that order ID can have multiple products associated with it. That's why for further subdivision of every single product, their quantity and price, we have created this order details table. I'm going to talk further about it in the next few slides. Okay, so there's a one-to-many relationship between the vendor and product table using the vendor ID field. Here it's the primary key. Here, this is the foreign key. The product and category table is the category table has a one-to-many relationship with the product table. The product table has a one-to-many relationship with the order details. And with this field, product ID is primary here, and the product ID is foreign key over here. The category table and product table has one-to-many relationship using this field, which is category ID. It's primary key over here and foreign key over here. The orders and the order details are associated using the order ID key. It's primary key over here and foreign key over here. One-to-many relationship, and the one-to-many relationship between customer and orders, because a single customer can place multiple orders, but any given time, a single order is associated with a single customer only. And the zip code table also has a one-to-many relationship with the customer using the zip code ID, which is the primary key over here and the foreign key over here. Now, um, after understanding this relationship between all these 7 relations tables, we can see that the referential integrity is enforced because you cannot add an order in this table without a customer already existing. So if a customer does not exist in this table, they won't have a customer ID. And if they won't have a customer ID, the order table will not accept that particular record. You cannot delete a product if it is used in order detail. Now, for instance, if a product's order was already placed, it would have already populated over here. Now, if you try to delete that product, it won't allow you to do that because it's already used in the order details table. So, it protects that particular record. You cannot enter a zip code ID in customer if it doesn't exist in the zip code table in the first place. So for instance, if there was a place like, for instance, Pittsburgh, Pennsylvania, if they're not, using that zip code in the table, they're not, open to those customers or not shipping over there in this case. So that won't be available in this table, and that record cannot be added. That zip code ID cannot be added in the uh, customer table. So that's how preferential integrity is enforced. So we're going to talk about all the normalized tables in 3NF. Firstly, we're going to talk about the vendor table. It contains the information of every single vendor, supplier in this case, um, their contact information, and the country, that they're located in. So we have 20 vendors over here, their email and their phone number. So this is a very important table as far as inventory management is concerned, as far as inquiring about products is concerned, as far as efficient communication with the vendors is concerned. Secondly, we have the category table. So how product table and category table is distinct with each other. How they're distinct is that a single product belongs to a single category, but a single category can have multiple products. For instance, under the luxury watches, you can have Rolexes, you can have Breitlings, you can have Omegas, you can have multiple kinds of luxury watches, and so on and so forth for all the categories. So we have 16 categories over here, their names and their descriptions as well. And then we have the product table. This is much more in detail. I could have added more records, but this is since, for um, showcasing purposes, I've only used 32 records. So as we can see, for instance, this particular product, Opal Diamond Ring, has a product ID of 607. This is the description. It's a 3-carat diamond women's engagement ring. It's priced at $2,800. We have 8 of them in stock. It belongs to the category ID 201. If we go back to the 201 category ID, it shows that it's an engagement ring. And the vendor ID showcases that it belongs to the vendor 405. The 405 is Karachi Gems in this case, with the email and phone number, as you can see. So just like that, every single one of these products is associated with a category ID and a vendor ID. And we can see that all of these are, all of these fields are fully dependent, function dependent um, on the primary ID over here. So it's in 3NF. Then we have the customer table. It contains the customer ID, the first name, last name, and their contact information as well. We can see they have the addresses over here, but they don't have the zip code. They only have the zip code ID. Reason being, if we add the zip code and then the state, the city, and all of that, so it basically becomes a transitive dependency, and it violates the 3NF. That's why we had to create a separate table for that. It has the address over here and the zip code ID. So for instance, if you want to know where this particular customer, Tony Stark, they live at 124 Stark Tower, but it's 8018. So where is it? 8018 is in Peoria, Illinois. And the zip code is 833. So it's a coincidence that both of them have 8, but so this is where, they live. So this zip code ID table, the zip code table, it basically contains the zip code ID field, the zip code, the city, and the state, showcases all the cities and states, and then the orders table. This table basically contains, the order table contains the order ID, the customer ID, the order date, and the total amount. So for every single order, um, we can see that the customer associated here, for instance, 3004, this order was placed by this customer 1022. So if we go to the previous table, 1022 is this customer, John Snow. So they placed the order, and the valuation of the order is $6,341.25. Now, if you want to know what they purchased, what's the order detail, we can go to the order details table, which is the next one. So 3004 for this valuation. If you look at this table over here, we can see that order detail ID is unique, but it can have multiple, uh, you know, um, repeated order IDs. For instance, this 3004 is populating here twice. This means that 3004 order has 2 items. Then there's a $6,000 item, and then there's a $341.25 worth item, which makes up 6341.25, which is populated over here. We can find out what those items are. This belongs to 629. 629 is basically an eternity band rings. We can see it's $6,000. And this is belonging to 602, which is this titanium dress watch, 39 millimeters, 341.25. So this is how the order table and the order details table works. As we can see in the order details table, there is no um, customer ID mentioned because it only focuses on the order ID and the associated products. And another important point is we have prices mentioned here, even though we had prices mentioned in the product table already. The reason being is that this is a real-time table. So for instance, if this watch today is 487.5, tomorrow it can be $500 or 525, and that change would reflect over here. But if a customer placed the order for, in this case, Mr. John Snow placed the order for this particular watch for 341.25, so it is showed as 341.25 here. Even then, tomorrow or day after tomorrow, if the price goes up to 375 or 400, this is not going to change. It might change over here. Because if we don't include this field over here, then we won't have any record of what the price was when the order was placed. That is why the price each column is necessary over here. Now we're going to talk about a list of queries that will showcase how this entire system is working. I have 13 queries that I'm going to use to show you how they're working. First of all, we're going to talk about how we can list all products along with their category and vendor names. So we're going to use this particular query over here, but I have already listed them here so that we can run them quickly and see the results. So this is our database. We have all these tables over here. So I'm going to go to the Create tab, Query Design. So this particular query allows the business to understand what products they have, what categories do they belong to, and what vendors do they need to contact in case they want to inquire about a certain product. Very important query in terms of business decision making. Now let's talk about a query if we want to show all the orders along with customer name and total amount, a summary of sorts. So we can use, as we can see, the order IDs reflected along with the customers. And I used um, the ampersand to combine the customer names in this case for a better view. And then the total amounts reflected of each order placed. We can see that the lowest valued order was placed by this customer, Leonard Hofstadter, and the highest amount order was placed by this customer here, Bruce Wayne, $22,500. So it can give us an idea of, what is the valuation of the orders placed by the customers. Moving on, let's talk about the third query. Here, we're going to list all the order details with their product name, quantity, price, and we can understand the details about the orders at length. We can see that every single order ID over here has a product name, the associated product name, the quantity, price, and the line total. So as you can see, for instance, if this particular customer, they had the order ID 3017, we can see that it's populated twice here. So they have ordered Rolex Submariner, Breitling Chromat, and their total valuation coming out to be 22,500. And just like this, we have, other orders showcased over here too. So it gives an idea of, how much every single customer, how every single order, how many quantities purchased alongside the price of each and the total as well. Moving on, we can do an analysis of what kind of customer segmentation marketing we can do. Where do our most customers belong to? So in this case, we can see how many customers do we have in New York. It can be any area, just to understand how this query works. We have used the example of New York. So as we can see, all these customers belong to New York in this case. Bruce Wayne, Dick Grayson, Clark Kent, Frank Castle, Karen Page, etc., etc. So what if we want to find all orders that include more than one product? In that case, because there can be orders that just have a single item, but what if we want to know about the orders that have more than one items? So in that case, we can see that these orders had multiple products, two in this case. 3001 had two products, this has two products, this has two products. Now this is important. What if we want to find out the stocks that we are running out of, the items that we are running out of? In this case, we have set the threshold for 5. So we need to list all the items that are lesser than 5 in quantity in stock right now. As we can see, all these items are less than 5. So it can give us an idea of the items that we're running low on, and they can be efficiently reordered. by the vendors. The most expensive product sold. It can give us an idea of the top of the line products that are not only there but are selling as well. They can be highly um, attractive items generating a lot of revenue. So it's important to understand um, what kind of products those are, and we can find them out. And you can see here it's Rolex Submariner, which is for $13,000. So it can like give us an idea of, the importance of this particular product in um the stock. Then let's talk about what if we want to find out the revenue, how it's performing every single day, the total order amount per day. Um, so it gives an idea of the sales that are being done. You can use this query. So as you can see, every single day, the daily revenue has been extracted from the tables, and this can allow our business decision makers to understand what needs to be done to um, make the revenue more and more consistent, to increase it, and monitor how it's performing every day. Showed vendors who supply more than two different products. In order to understand what kind of vendors we have that are more resourceful than others that can provide more than a single category of products. In this case, Prime Jewels, they um, have three different kind of products that they are offering us. Now, if you want to list the customers who haven't placed any orders, so for instance, they stopped by, they came to the website, or they came into the store, they gave their information. That's why they are in the customer table, but didn't place any order. So it's very important marketing wise to address these customers, try to get their attention, and try to target them and create a sale. So for that, you can use this query. It will show you all the customers that are not populated in the order table because they haven't placed an order. Moving on, is the top 5 most sold items by quantity, not by revenue generated. The most, selling items, the items that move very fast. To find them out, we can use this particular query over here. Again, these are all the same queries that are in the slides. I've just put them here in the notepad so that I can test them quickly in this short presentation. So these are the most selling items: stud earrings, cross pendants, gold bands, etc., etc. So it gives the inventory manager an idea of what items to stock more compared to the rest. Show how much revenue each vendor's products have generated. This is a prime example of understanding vendor performance. Which vendors are more valuable than the others, whose products are generating more revenue compared to the others. An important decision. As you can see, it's in descending order. So Oswald Co. is the highest revenue generating vendor for us in this case, then Goldmine, then Newport Inc., etc., etc. The lowest performing, the least performing vendor in this case is Yu Brothers, because The revenue generated from them is just $600. And then the final query, which shows all products that were never purchased in any order. The orders that are just sitting there, that are not moving at all. So the business would like stay away from these products or not stock them as much as the rest because they're just sitting there and not selling. They're probably are not in demand. So it's also a very important um a very important thing to observe that these items, cross ring, diamond earrings, diamond bracelet, Figaro bracelet, radiant diamond ring, these are not selling. So there is no point in stocking more of these. So again, this was just a brief overview of how this particular database is working, and it's um, I would say it is a very basic but very important project in order to understand how these major businesses running today they use their database systems to perform all these operations, and business decision making is being done every single day. They're using more advanced, sophisticated tools, but the fundamentals are the same. Database administrators, the data analysts are used. The database administrators, they make sure that the entire database you know, is secure. It is um, always backed up. It's up and running, and the data analysts are always performing different kind of algorithms and queries to perform analysis for better decision making. Um, thank you so much once again for your time. If you have any questions, please you can always reach out to me. Thank you so much once again.